All right, so this video we're talking about similar shapes, and specifically we're talking about triangles in this one, and on the next slide I'm going to talk about other shapes. So the angle-angle theorem states that when comparing two triangles, and this only goes for triangles, if two of the corresponding angles are congruent, then the two triangles are similar. Remember, similar is represented by that symbol, the little squiggly line. I don't want you to mix up the word corresponding when we're talking about these and corresponding when we're talking about parallel lines cut by a transversal. They're very similar definitions, just they're not exactly the same thing. So on the board are two right triangles. So right away, I'll call 1, 2, 3, 4, 5, 6. I can see that angle 1 is congruent to angle 4. They're both right angles. And let's say you were given angle 2 was 30 degrees and angle 5 was 30 degrees. Well, then we know that angle 2 is congruent to angle 5, and therefore we know that triangle 1, 2, 3 is similar to triangle 4, 5, 6. Let's say they gave you, but you have to be careful. So that's when they give you all the information that you're looking for. They're not always going to be that nice. So let's say instead of giving you that angle 5 was 30 degrees, they gave you that angle 6 was 60 degrees. And a lot of you right away would go, okay, 90 is 90, so 1 equals 4. And, well, one says 30 and one says 60, so those aren't congruent. So these are not similar, definitely. But you have to be careful. You have to find the missing angle first, and then compare them and see if they're congruent. So in this first triangle, 1, 2, 3, I know that all three angles of a triangle add up to 180. 90 plus 30 is 120. Therefore, this missing angle has to be 60. So now I have a matching angle, a matching angle, matching angle, a matching angle, and they're similar. So that's something you have to be careful of. Let's look at other shapes now. Other shapes do not follow the exact same theorem. When you're talking about other figures and similarity, you need to have corresponding congruent angles. So you always have to have that. Triangles and anything. And, so this is an end now, you also have to have proportional sides. The corresponding sides need to form equal ratios. So we're going to do ratios as fractions. So you set up two fractions, you set them equal to each other, cross multiply. If they're equal, then they are proportional and therefore similar. If not, then they're not. So let's look at an example of that. So I'll do, let's do two parallelograms. So these aren't drawn to scale, just bear with me. We'll call this side 3 and this side 8. And then we have and we'll call this 120 degrees and this 60 degrees. And we'll have a smaller parallelogram. And we're going to call this 1.5 and this 4. But the angles are going to be the same, so 120 and 60. So are they similar? Well, let's see. They have corresponding angles. Since this is 60, I know this is 60, and I know this is 120. Same on this figure. So the corresponding angles are congruent. We're good there. Now we just have to see if the sides are proportional. There's two different kinds of ratios you can set up. You can set up the corresponding sides. So 3 corresponds to 1.5. So 3 over 1.5 equals, and then 8 corresponds to 4. And you just have to check if these equal. Multiply 3 times 4 is 12. 8 times 1.5 is 12. Check. So they are similar. The other ratio you could set up is when you take both sides of the same figure. So the two sides of the first parallelogram are 3 over 8. And the two sides of the next parallelogram are 1.5 over 4. You just have to make sure, if you're going to use the slanted side on top, then you have to use the slanted side on top over here. You can't mix that up. So again, 3 times 4 is 12, 1.5 times 8 is 12, and you're done. They are similar. That's the other fact that you need to know about triangles. In triangles, so we have that angle-angle theorem, but what if they don't give you anything with angles? What if they only give you information about the side length? Then you have to make sure if their sides are proportional. In triangles, if their angles are congruent, then that's enough to tell you that they're similar. If their sides are proportional, that's also enough to tell you. So if this is 10 and this is 5, and then this is 6 and this is 3, you can check to see if they are in proportion. So 10 over 6 equals 5 over 3, or 10 over 5 equals 6 over 3, or 3 over 6 equals 5 over 10, something like that. As long as you're making sure that you're always matching up the sides. You're always keeping the corresponding sides either in the same ratio, or in the numerator, or in the denominator, always in the same place. So that's it for this video. Similar figures will be on the test. I know we haven't done it in a while, so definitely review them, go over the notes. They're all online, do some practice problems, come in with questions.